Hey there, mathematicians. Justin here. Mia and I just had a great meal. This restaurant doesn't have an option to split the bill, so I'll pay for everything, and then Mia, you can send me your part. Ooh, I'm not sure the exact amount of money you owe me, Mia, but this is a perfect chance to use math skills, like the order of operations and writing expressions, to find out. Let's look at what's on today's math menu. We'll be writing complex expressions to represent real-world situations and applying the order of operations to evaluate real-world problems. Let's get into it. Okay, so first we need to look at what we ordered. On our receipt, we have all these items. Mia, you could just send me half of that. Wow, that was easier than I thought. See you Oh, you're right. That might be unfair since one of us probably ordered a little more than the other. I know. Let's mark the items we are each responsible for. Angus burger, you. Bison burger, me. Onion rings, both of us. 2 apple juices, you. And the OJ, me. Did not go great with the beef, but now let's cross off the food I had by myself so we can just focus on the items you had. And done. To find out how much Mia's responsible for, do you think we can just add these numbers together? No, because some of the items are shared or Mia had more than one of. There are different operations happening here, so it's a great idea to represent this situation with an expression to better organize the math. What operations do you think we'll use to write this expression? If you're stuck, the warm-up on the cover sheet of the lesson materials might help you out. Feel free to look back at it if you'd like. Pause now to jot down your predictions in your guided notes. We'll need to evenly split the shared onion rings between Mia and I, so we'll divide by 2. Mia had 2 apple juices to herself, so to get the cost, we'll need to multiply the $2.50 by 2, and finally, we use addition to put it all together. Now that we know what operations to use, let's write the expression for how much Mia is responsible for. She had the Angus burger for $12.50 by herself. Then the onion rings, so we add the $5.50 divided by 2. Then the 2 apple juices, so we add the $2.50 multiplied by 2. We just wrote a complex expression to represent a real-world situation. What would the order of operations be for this expression? Pause here to jot that order down in your guided notes. According to GEMS, we'll do the division and then multiplication since it's from left to right, and then the addition. But let's make sure this exact order matches what's happening in the situation. To figure out Mia's total, does it make sense to do division and multiplication before the addition? Yeah, it does. But why? Well, we have to divide the cost of the onion rings to get just Mia's portion, and then multiply the apple juice price to account for both juices she ordered. Once we have those subtotals, then we can add everything together to find the total. So yes, this order does match because we have to divide and multiply some of the items before adding them together. Okay, so if we apply the order of operations, that means you will owe me... Oh, sweet! Mia has a $4 off coupon for onion rings. But that would change up our expression a bit. So, if Mia has a coupon for $4 off the onion rings, what operation should we use to show that discount? Yes, subtraction. But where would that subtraction sign go in our expression? $5.50 is the cost of the onion rings. And remember, Mia and I split them. So the cost is being divided by 2. How can we rewrite this part of the expression to represent that $4 discount? Pause here to rewrite this part of the expression. Since the $4 is coming off the cost of the onion rings, this part of the expression looks like this, but I'm not confident. Let's only focus on the onion rings part for now. Based on gems, what order would I do this in? Yeah, division, then subtraction. We would divide the 4 by 2 before subtracting that answer from the 550. But does this exact order match what's happening in the situation? For the onion rings, does it make sense to divide before we subtract? Pause now to jot down your thoughts in your guided notes. It makes more sense to subtract first here to apply the discount of $4 to find the new cost of the onion rings, and then divide that by 2 to split the cost. So, what do we need to include in this expression to signal that the subtraction is performed first? We need to include parentheses around the subtraction in the expression. This will signal us to do the discount first, and this is our final expression. Go ahead and evaluate this expression using the order of operations. On pause when you're done. Let's calculate what's in the parentheses first. Then we take care of the division. Next, we do the multiplication. And finally, our last operation here is addition. Okay, Mia, we got it. You'll owe me $18.25. While we're getting ready to pay, let's put our skills to the test in 2 practice scenarios. Mia buys 3 lemons costing $2 each and 4 avocados. Each avocado costs $3, but they're currently $1 off each. Write and evaluate an expression to find out how much Mia will spend in total. What operations do you think we'll use to write this expression? How can we find how much Mia spent on 3 lemons costing $2 each? Right, we can multiply the 3 lemons with the $2 per lemon. If Mia buys 4 avocados and each avocado costs $3, how can we find how much Mia spends on avocados? We can multiply the 4 avocados and the $3. What else do we know? Yeah, there's a sale for $1 off the price of avocados. What operation will be used here? Right, subtracting 1. What do we have to do to find out how much Mia will spend in total? We need to add everything together. Okay, now that we have the different pieces of the expression, go ahead and write an expression to represent this situation. This is what I have so far. I made sure I subtracted the 4 times 3 by 1. Based on gems, it would be multiplication, then subtraction, then addition. But does this order of operations accurately represent the situation? For this avocado part, does it make sense to multiply 4 and 3 before subtracting by 1? That wouldn't make sense. Why not? It says the avocados are $1 off each, so we need to apply the sale of $1 off first to find the new price of avocados before multiplying it by 4. In order to make subtraction first, what do we need to include? Yep, parentheses. So let's update the order with the groupings first, so the subtraction inside the parentheses will be done first. Now we're ready to evaluate the expression. Pause now to evaluate. So, following gems, parentheses, multiplication, the other multiplication, and addition, and Mia will spend $14 in total. Okay, one more. 8 cards are taken from a deck of 52 cards before being split evenly between 4 players. Then, 1 additional card is given to each player. Write and evaluate an expression to find how many cards each player has. Okay, so 8 cards are taken from a deck of 52 before it's being split evenly between 4 players. What would that look like in the expression? Yeah, 52 minus 8 and divided by 4. And since we divided this, we're getting how many cards each player has so far. Then it says 1 additional card is given to each player. What would that look like in the expression? Yep, a +1. Looking at this expression, what would the order of operations be? The order of operations of this expression is division, then subtraction, and then addition. Does the order of operations accurately represent the situation? Pause now to jot down your thoughts in your guided notes. So it wouldn't make sense to do division first because the 8 cards are subtracted before the remaining cards are divided by 4. So I need parentheses around 52 minus 8. Okay, how about now? Is this current expression correct? Yeah, it's correct now because the parentheses tell us to first subtract the 8 cards, then divide the deck, and then add the 1 card, which matches the order of operations in my current expression. Go ahead and evaluate this. Okay, here's the work. And each player has 12 cards. Whenever there's a situation that involves a lot of different operations and steps, it's a good idea to write an expression to represent that real-world situation, and then apply the order of operations to evaluate. With these skills, you helped Mia and I split a bill fairly, and you'll get to explore some more useful places to use these skills in the rest of this lesson. See you next time! Hey, hey.